Newton's laws of dynamics describe how forces act and affect motion. Unless some external force changes its state of motion, an object at rest remains at rest, and a moving object continues to move forever in a straight line with constant speed. This is Newton's first law, also known as the law of inertia. Inertia is the tendency of an object to keep moving at the same speed and in the same direction unless acted upon by a force. The greater the object's mass, the more inertia it has, and the greater the force needed to change the motion. Thus, if an object is changing its state of motion, there must be a net force acting upon it. As we know, a change of velocity, either speed or direction, implies that there is acceleration. So when a force is applied on a body, the body is accelerated. But the effect will be different depending on the object's mass. For the same force, the more mass, the smaller the acceleration. This is Newton's second law. The acceleration of a system increases with the force applied on it, and decreases with its mass. This law is best known in the form of this equation: force equals mass times acceleration. Newton's second law also defines the standard unit of force. In the International System of Units, force is expressed in kilograms times meters per second squared. This unit is called Newton. But forces act on objects that are interacting with each other. So, as one object exerts a force on another, the other object exerts a force on the first one as well. These forces are equal and opposite. This is Newton's third law, also called the law of action-reaction. Mathematically, we can express it like this. It is important to keep in mind that these forces act on different objects, and therefore they do not cancel out. Otherwise, a ride on the bumper cars wouldn't be so much fun. And we could not send rockets to space.